Hi everyone! So as promised, here's some explanations on how to graph derivative of a function. And remember, we're going to go from function to derivative and also derivative to function as well. So focus and follow along, okay? Hi! I'm here, okay? Alright, now first of all, it's really confusing when you're graphing original function to a derivative because you keep confusing yourself to thinking that you're graphing the actual function. So to avoid that, always just remember, derivative is the slope of the original function, and also derivative is you're thinking increasing, decreasing, negative, positive, right? You're thinking about all those things, okay? All right, so let's focus on that, okay? What comes to mind when you think of derivative? Yes, I hope the word slope, slope, slope. So for example, let's say we have this graph here, negative x squared plus 3, and we have to find the f prime of x and graph it. Well, a couple of things for you to keep in mind is this. You're graphing the slope of this guy here. So, I mean, of course, you can do the quick derivative here. You get negative 2x, so you're like, oh, the slope is negative 2. You can think of it that way. You can also think, well, this is a quadratic, so you know when you graph your derivative, you have to get a linear. So always 1 degree down, right? Okay, so let's actually discuss that, okay? So I have this graph. Oh, you're not supposed to see that, so I'm going to put my phone here, okay? So you're going to graph, right, of f of x. Now, this is your graph of f of x, negative x squared plus 3, the original, right? So think about this. I always do this first. I'm like, okay, it's increasing here, so I put a positive here. Okay, it's increasing there, but it's decreasing starting here. At 0, it starts to go decrease. That means it's positive here, it's negative here. That means it's above the x-axis here, it's below x-axis here. And this 0 is super important because this at 0, the slope is 0. That means it crosses the x-axis at this point. So, but you got to do this naturally. Don't ever do this like so rigid, okay? Keep the flow and make it smooth. So for example, you knew that, well, you can do the derivative, it's easy, but not all the time can you do the derivative as easy as this. Of course, we know that this derivative is f of negative 2x, so you're going to essentially graph this function here. But not all functions are that easy to take the derivative of. That's why it's important that you know how to do this, thinking about all this. Positive, it's increasing, it becomes a 0 here, it's negative. So what I do is I always start with the 0. I put a little 0 dot everywhere that's 0. So I put a 0 here that starts with there. Because I know the slope is 0 at this point here. So I did that. Now it's positive, that means it's increasing. So I know it's positive here. And I mean, you can, and then slope is constant here, so you know it's constantly here, positive. It's above the x-axis. But here, it's negative, constantly negative, so it's negative all the way down. And you should always understand the relationship here. It's a quadratic, and this is a linear, okay? That was the easy one. Let's try another one, okay? Let's try another one. Okay, let's try another easy one. So I have here the graph of 2x minus 5. Remember, we're going to graph its derivative, which you know its to be is 2. So you can think of it that way, but remember I told you, it's not always that easy, right? So now this graph is a linear, so you know the graph of its derivative is going to be a linear as well, but not linear like this. It's going to be either a vertical or horizontal line. So this one is going to be, well, look, it's growing constantly of a slope of 2. Slope of 2. So all you do is you graph a line of 2. Okay? So this is the graph of its derivative. So think of it this way. If I gave you the graph of derivative is 2, you should be able to know the other way around. Of course, you won't know the x-axis or the y-intercept. It's okay. As long as you show me that on your f of x that the slope is 2. Okay? So we're going to try a harder case. Okay, try to explain that to one another. See if you understand, okay? Okay, let's try another easy one. Okay, now by now your sub should have given you this worksheet. It's got about 7 pages or 8 pages. It's called 4.4 Graphing Derivatives, and we're going to actually go through all this together, okay? Let's start with this guy here, okay? So we're going to go little by little, okay? Let's try this one here first. So you're looking at this page here, okay? That's the first page that the sub gave you, right? So you're trying to matchy-matchy in this case. And the matchy-matchy should be pretty simple for you. Okay, so you can always do it this way, the cheating way. You're like, okay, this is a linear, this is a quadratic, this is an absolute value, this is something weird, this is a cubic it looks like, and this is something funky too. So for now, while I'm not there, we're going to skip this guy here, but we should be able to do all this. So we're right now identifying which of the original functions goes with their derivatives. So again, we can do it the cheating way, but we can also kind of sketch things, okay? So let's actually, like, if you were doing this mentally, you'd be like, okay, this is the original function. It's increasing. Oh, there's a 0. It's increasing. So it's constantly increasing. Oh, it's constantly increasing. Which of the derivatives depict constant increase? But this is also a linear, so you know it's going to be either a vertical or a horizontal or a vertical line. So you're right. Which one do you think it is? Take a guess. Yes, I hope you said B. Okay? All right, let's go to a harder case here. Okay, let's go here. Again, let's point out all the zeros. Where is the slope 0? It's increasing here, it's decreasing here, but here is the 0. So right here at 0. So which of the their derivative graphs show 0 at 0? That means it crosses a 0 at 0. Okay, so that should be another way. I'm sorry, I put a positive here. You're right. It's decreasing here, so I should have put negative. That means in this derivative graph, it should be above the x-axis here, below the x-axis here. So the only one that looks like that is what? Tell each other. Check your answer. Did you guys get D? Because look, it crosses a 0 at 0. It's positive here because remember this is the graph of the derivative. It's in the positive region above the x-axis. But this guy, it's negative, so it's going down, right? In decreasing, it's below the axis. And also it's a quadratic. This is a linear, right? Okay. Now let's try this different weird case here. What's happening here? What happens to the derivative here? You're right. It does not exist because it's a sharp turn. No derivative. No derivative, okay? That means something weird happens here and something weird happens here. What's happening here? It's decreasing constantly. It's increasing constantly. It's increasing constantly, it's decreasing constantly. That means it should be below the 0 here on this before this weirdness. It should be above the 0. And we could estimate the slope here. What are you thinking about? I don't know, maybe 2, negative 2. So maybe this guy's positive 2. So all you're going to do is graph that onto the derivative graph. So which one looks like that? Take a guess. Okay, I hope you said A. Why is it A? Because look, it's negative until this weirdness. So undefined, the derivative is undefined at 0. It's negative constantly from negative infinity all the way to this 0. And then from 0, it's positive 2. Remember we said that this is like maybe a slope of negative 2, slope of positive 2. So we're graphing literally the slope, negative 2 and positive 2. Okay? Now don't worry about this one so much, but try it with your friends, this guy here, okay? I didn't leave you very much, but you know what? I think maybe this one might be worthwhile. So where is the slope 0? So let's write a couple of things down, okay? What's happening here? Oh, you mean it's a positive slope here? You're right. But what happens here? It's also positive. So let's write a couple of things down, okay? This is a positive slope all the way across. Let's see what else we can write. We can also write that this is a cubic function. We should be able to recognize that. It's a cubic. That means our slope derivative graph is going to be a quadratic. Also, it's increasing all the way. It's increasing all the way. So which of the graphs here depict this scenario? It's always positive. So let's see which ones are always positive. This guy's always positive. This guy's always positive. This guy's kind of positive, but it's undefined at 0. This guy doesn't look like it has any undefined values. So the only one that makes sense is C, but let's see if that makes sense. Is this a quadratic? Yes. And look, it's constantly growing, but it's you know how right here, so this is where it comes up here. Isn't this concave? Is this up or down? This is concave down. This is concave up. So again, here, look at this. It's this way and this way, up. Maybe that's a little bit hard for you to see right now, but don't worry. Look at this. It crosses a 0 here too, right? So that's another thing that you could point out, okay? It's positive, positive, so positive, positive, okay? Okay, good luck with that, and watch the next video for more help. Bye. I'll be back.